NASA prepares to develop its next large space telescope. Following the immediate success of the James Webb Telescope, one would expect NASA to focus on other projects. Apparently, that is not the case since NASA is embarking on developing its next-generation space telescopes, which we will discuss in today's video. But before we continue with today's video, I would like to request you to subscribe to our channel. Subscription is a brilliant way of supporting our channel, and I really appreciate all of you who support our channel through subscription. A big thank you for that. So, NASA is currently working on the next generation of its space telescopes, which are expected to launch in the 2040s. The purpose of these telescopes is to look for habitable planets outside the solar system. By looking for planets like this, humans may be able to find intelligent life elsewhere. The James Webb Telescope was not designed to look at exoplanets, and still, it has produced some very amazing results in terms of spectral data which it has sent back to Earth. To date, this spectral data has been collected from TRAPPIST-1. This galaxy involves 7 Earth-like planets orbiting a red dwarf. A red dwarf is essentially a star, which is cooling down and is at a lower core temperature as compared to our Sun. The spectral light reflected from the atmospheres of these planets will be instrumental in telling us about the composition of these planets' atmosphere. The composition and distribution of gases in these planets will be able to tell the scientists if these planets can harbor life. The purpose is to look for Earth-sized planets, which are located at a comparable distance from the Sun for ideal temperatures. It is not possible for the James Webb Telescope to gather data of this type, since it collects data through transit spectroscopy, which means that we are not able to access all this information because we take so long to orbit around the Sun. A possible solution to that problem is the Nancy Grace Roman Space Telescope, which is projected to launch in 2026. This telescope will have a 2.4-meter diameter mirror, which will have the ability to gather enough direct images of gas giants. But even the Roman telescope will not be able to block light sufficient to capture images of Earth-like celestial objects. So what kind of telescope will NASA use to know more about exoplanets? Right now, to determine if there is life on any exoplanet, will require more powerful and sophisticated equipment. If this telescope is launched into orbit by the 2040s, it is speculated that scientists might be able to find planets capable of harboring life within a single lifetime. But what would this telescope be? This telescope will be a combination of 2 systems, the Habitable Exoplanet Observatory, or HAB-X, and the Large Ultraviolet Optical Infrared Surveyor, or LIVOIR. The concept was first given acceptance in the Astro 2020 Decadal Survey on Astronomy and Astrophysics. The scientists have recommended that a combination of LIVOIR and HAB-X telescope be used, which has been called as LUV-X. The telescope has also been called as IRUV, which has been labeled so because of its capability to capture data relevant to infrared, optical, and ultraviolet light. The LUV-X has a 6-meter diameter mirror, which will be enough to capture images of about 25 Earth-like planets. After a year from Astro 2020, there are calls for this telescope to be integrated into NASA's Great Observatories Maturation Program. This program will be a 3-step process that will eventually allow this new telescope to take form over the coming years. Right now, NASA has not even announced the final team for LUV-X. In the month of April, scientists met online to discuss some of the foundational science which will be needed to implement the technology necessary for constructing the telescope. NASA does plan to ask for precursor investigations by 2023. Precursor investigations include narrowing the regions of the universe, which are ideal for the telescope. This could be done by spotting the gravitational attraction of these planets from their respective stars, which is a process called radial velocity. This science is not well developed, and therefore, more precursor investigations will be needed to be explored. It has not been decided which construction materials will go into the primary mirror of this telescope. Not only that, scientists are also unsure about the nature of this primary mirror. For example, they do not know if the telescope will be a huge monolithic design like the Roman telescope, or will it be graduated into different pieces like the James Webb Telescope. A monolithic design seems to be a better option at this point, since it is less complex in design and can easily fit inside 2 of the largest rockets that we have today, SpaceX's Starship and NASA's Block 1B variant of Space Launch System (SLS). It is also being considered as to how the telescope will be capable of blocking lights so that images of rocky planets can be captured. Some scientists have already decided where they would like to study these Earth-like planets from. The binary star system of Alpha Centauri A and B are a good first candidate. So, although the design elements and the overall working principle has been established, much work remains to be done. The most important thing which NASA will aim to do is to avoid the schedule delays and budget issues which the Webb telescope had originally run into. The project was originally valued at $1 billion in 2007, but could only be accomplished at $10 billion in 2021. This concludes today's video. Do not forget to like the video if you found the video informative. Thank you for watching till the end. See you in the next one. Peace out.